Welcome! In this series of short videos, we will look at topics for both the PowerBasic window and console compilers. Today we will look at the topic of code review. As a programmer, you may well be writing programs that are entirely for your own use. In which case, as long as the program actually performs and does exactly what you want, you probably don't need to do a great deal of review because you're the only person who's ever either going to be using the application or to be programming and changing it. However, if you're a professional programmer or a programmer who works with a group of other programmers, you may well have to pass your source code on to another programmer to make updates. And in this case, it always helps if your code is well written and documented. Also, if you are writing many programs, it may be some months or even years before you have to go back and make a further adjustment to your program. So what do we mean by reviewing your code? First of all, we need some code to have a look at. However, while this video is perfectly applicable to both the console and the Windows compiler, I'm going to be using some code from a recent video we did on the Windows compiler. This particular application displays a graphics map on the screen on which bitmaps are then positioned. However, what the program actually does is mostly irrelevant. What we want to do is to look at the application to see if there's any way the application can be better written. So if we have a look at the code itself, and inside the event handler of the single dialog in this application, there are a number of routines which are run when the dialog is initialized. We have a build random terrain and a build graphics map. Obviously, building a lot of your code inside functions makes the code much easier to read and much more maintainable. We're going to have a look at the fun build graphics map function. Now, inside this particular function, there is one piece of code which is also used within other functions. This section of code here, where we're opening up a file which happens to be a bitmap, and we're reading some information from that file. In this case, to get the width and height of the bitmap. Now, this particular piece of code exists in other functions. If we have a look for anywhere in our application where this for binary piece of code appears, we'll find that's one iteration of it, 2, 3, 4, 5, 6 iterations. So this particular piece of code is used in 6 places within the application. Now, when you have a piece of repeating code like that, this is ideal for putting into a standard function, because if you use it 6 times within this application, there's a good chance you'll actually be using this type of code in other applications as well. So it's crying out to be put into a library. So what I've done today is to create a new bitmap graphics library and a standard function to get the bitmap size. We're not going to be making any functional change to the application. We're just going to restructure it slightly so that first of all the code is more easier to read and the code is more maintainable. So the purpose of this particular function is to get the bitmap size. If we look at our original code, we'll see in here, if we go back to our original function to build a graphics map, we're setting the location and the name of the file into one variable, and we're then executing this piece of code. So rather than this piece of code we have in here, we're going to put in a call to our new generic function. This generic function will take 3 parameters. The bitmap name, the width and the height as being outputs. Now, since we're populating these here, we will not need this piece of code. And I'm putting it in an if statement because if the bitmap doesn't exist, then we don't want to execute this next bit of code. And we'll put our end if down here. So this new function exists in a new library. So what we'll do so we know where we are is we'll put a bookmark on this one, and we'll go back to the beginning of our code, and we will slot in our new library. So having slotted in a new library, we will go back to our bookmark and we will change the parameters for these parameters here, which is the ones this particular function is actually using. So if we try running our code now, we'll see our code operates as normal. So the slotting in of a new function does not change the program functionally. We've just removed a section of code. Now we can repeat that process through the other functions that actually have this section of code. So we don't need that section anymore, we'll just take it out completely. The other change to make is down here. In each of these functions we're loading up the bitmap using a graphic bitmap command, and we're using a graphic copy to put it onto the screen. So this is basically pasting in a bitmap. So in our common library I've created a second generic function whose job it is to paste a bitmap in, giving it the names of the files, the width and height, and where on the screen it's to appear, and the handle to the graphics control. So how do we replace that piece of code with that? Well, after we've actually named the file, all we need to do is to call a new function like so. We can comment out all this code that follows it, and we'll just change our variables to match the variables in this function. Now if we try running that now, again our code works perfectly. So we've now removed another bit of common code. So all this can go. So we'll now see that the code itself is a lot more readable. There are fewer lines of code, and each of these functions will do exactly what you want. So that's the first part of your code review. We'll then go through the rest of the code and actually remove all this extraneous code and call the common functions. So having done that, if we look at, for example, the setBuildings function, we'll see that it's now using the getBitmapSize, and it's using the pasteBitmap function. So if we run that code now, it runs quite nicely. So we've reduced the number of lines of code in our application, and it made it much easier to understand. That's the first stage of looking at your code. Now this particular task is quite laborious. It involves you actually understanding your code and actually looking for areas that can be made into common functions. However, there is a utility that was written quite some years ago called PBCodec, and this has been covered quite extensively on the PowerBasic forums. Now PBCodec is an application written in PowerBasic that can be used to scan your application and actually check to see whether there's any variables that are not actually used but still defined, or any functions or subroutines which have been defined. Now PBCodec comes with a number of options. At the moment everything is ticked. It's going to report on any unused functions, subroutines, global variables or local variables. And it will also give you reports on all these different items. So in order to use PBCodec, all you need to do is to drag your source file into this area or browse to it. So if we drag our graphics mask application in here, it will give you a report on the screen. So here's the report on screen. It scans your code very quickly. It tells you the main source files, and it tells us that there are actually two functions within our application which are not actually used. The readRawHexTerrain and the buildGraphics functions. Now these are functions that can quite happily be removed from your code because nothing's calling them. The other useful bit of information is in here, the unused local variables. So there are a fair number of local variables which are not used. So let's have a look at line 303. So here's line 303. It says that the end file variable is not actually used. So having taken that variable out, we'll just save our program and rescan. and the line for 303 is gone. So HBMP is not used, so that one can go. So let's run our application to make sure the removal of those variables didn't adversely affect our program. In other words, was PBCodec correct in saying that these variables weren't used? Well, our program's working perfectly well. So PBCodec can quite happily be used to detect where variables you set up are not used at all, and therefore can be removed. The reason these can be removed is because the functionality they performed is now being done in a generic function. Now this can quite easily be missed when you're working in your program constantly and changing it all the time. So let's go through this and remove a few of these. So it's just a matter of working down this list and removing all these unused local variables. So the act of removing all of these unused variables will make your code much cleaner and tidier, and should you need to pass your code on to another programmer, there's less for them to understand and there's less for them to misunderstand. So since it actually said that there are two functions we're not actually using, the fun_build_graphics, let's have a look at those. There's fun_build_graphics. So we'll just comment that entire function out. And we'll run our code again. Now again, the code runs perfectly, so that function was not indeed used. And the other one it says we can get rid of is the redraw hex terrain. So we'll just lose this function completely, and we'll look for the redraw hex terrain, and we'll just take that one out as well. And our code still runs fine. So if we rescan our application, those are now disappeared from the list. We also have a function draw hex, which is unused. So let's lose that one as well. These were obviously created when we were developing. It's not unusual to have routines which are created during development and end up not being used. And our application still runs perfectly well. So we've got rid of all the unused functions, there are no unused subs, we have no unused global variables, just a few more local variables to tidy up. The other thing that this particular application does, it gives you a reference count of how many times individual functions or subroutines within your application are actually mentioned. So you can see which function is actually used the most. And the same with your global variables. So I will include the source for PBCodec version 1.5 with the rest of the source code for this application to allow you to recompile it and use it yourself. There have been a number of developers on the PowerBasic forum who have actually contributed to PBCodec, and I've only made a very minor change to ensure it compiles with PowerBasic Windows version 10. So this has been a short introduction to code review. Hopefully you'll find this useful in your own applications. That's it for today. Thank you for watching.